Hi, this is the correction of the quiz 2.1 to 2.3. So, question number 1. An object is moving with constant non-zero velocity in the x plus direction. The position versus time graph of this object is a straight line making an angle with the time x-axis, because in a position versus time, the slope it will be velocity. So it's constant non-zero velocity, zero velocity. Second, an object is moving with constant non-zero acceleration in the x plus direction. The velocity versus time graph of this object is a straight line making an angle with the x-axis, because in a graph of velocity versus time, the slope will be acceleration. So we want the acceleration to be constant non-zero. It has to start here and be constant. So the slope of a velocity versus time graph gives acceleration, because velocity versus time will always, the slope be acceleration. Number 4, which of the following quantities has units of displacement? Displacement is a vector, so we have to put the direction and magnitude. This is the only one that gives direction and magnitude. So it's 40 kilometers southwest. Number 5, suppose that the object is moving with constant velocity. Which statement concerning its acceleration must be correct? The acceleration is equal to 0, because constant velocity is equal to 0 acceleration, and changing velocity is equal to acceleration. So, number 6, which of the following graphs represent an object at rest? So, an object at rest must be at the same position always. And we have to have a position versus time graph. So this is velocity versus time graph, so this is not. So we have position, 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 position. This is not possible. And the object at rest is same position, so we have to have the same position always. It's this one, because the position doesn't change.
Okay, I would talk to you about the correction of quiz 2.4 to 2.5. Well, the first question, it says, two figures shown as a graph of the position x of two cars, C and D, as a function of time t. Okay, so I did a sketch here, and we can see that the correct answers are that both cars have the same acceleration and that the cars meet at time 10. Because we can see that here, both cars have the same acceleration and they also meet at time 10. Okay, question number 2. The motion of a particle is describing the velocity versus time graph shown in the figure. Okay, we can see this graph. It starts here about 2.5 and then it crosses the x-axis at almost 4. We can see that its acceleration, it remains constant and it doesn't have change. It grows, but it doesn't have really a change. Question number 3. Suppose that a car traveling to the west begins to slow down as it approaches a traffic light. Which of the following statements about its acceleration is correct? Okay, so I did here a little drawing. This is a car that is going towards the east and it starts to approach a traffic light. Its acceleration is towards the east because it begins to go this way so that the car can slow down. Question number 4. An object is moving with constant no-zero acceleration in the plus x direction. The velocity versus time graph of this object is a straight line making an angle with the time axis. Here we can see that here it's velocity versus time, and the graph should go this way, making an angle over here, approximately. Question number 5. If the velocity versus time graph of an object is an horizontal line, the object is, well, I did here another sketch, and we can see that it is moving with 0 acceleration because the velocity is not changing, it remains constant. Which of the following situation is impossible? Well, over here the situation that's impossible is an object has constant no-zero velocity and changing acceleration, because if an object has constant velocity, it has 0 acceleration, but if it has changing velocity, it has a non-zero acceleration. Question number 8. If the velocity of an object is 0 at some point, then its acceleration must also be 0 at that point. Well, that's false, because like here with free fall, we saw that at the highest point, which would be here, its velocity is 0, but it still has acceleration. In that case of free fall, it would be the acceleration of gravity.
Here in question number 9, an auto manufacturer advertises that their car can go from 0 to 60 in 8 seconds. It's a description of what characteristic of car's motion. So from 0 to 60 is velocity, in 8 seconds is time. So in a graph of velocity versus time, the slope will be acceleration. So we have here average acceleration.
Number 10 tells us to draw three graphs. Graph A is a position versus time graph for a movement with constant acceleration. Well, we can see here that, as we can see, it's position versus time, and here it's a movement with constant acceleration because the position is changing. Graph B, it's a velocity versus time graph for a movement with constant acceleration. Okay, so the velocity is growing according to time, and this is the acceleration, which is constant. And graph number C is acceleration versus time for a movement with constant acceleration. Okay, so because it says that the acceleration is constant, the acceleration will remain this way according to time.